Alrighty. So this conversation here, we have an awesome group of panelists put together, as well as Shad from NSI. We're going to be talking about the advancements in operational design and deployment for AI data centers. AI data centers, or AI warehouses, whatever you want to call them. A little bit different than a traditional data center, less requirements on network connectivity, among other things. We'll delve into that and more, and talk about how to integrate new technologies within your facilities. So take it away, Shad, self-intro, and get things going.
Well, thank you all for coming out this morning. My name is Shad Seacrest. I am the Director of Data Center Solutions with NSI Network Infrastructure. We've got a great panel here today, a lot of different experience. It's going to be great because it's a little more raise floor and out type of group here. But we'll be discussing AI, with it being all the hype. It's in the early phases of adoption. What's really going to happen with that? How are the data center operators and engineers looking at integrating the right power and cooling technologies and infrastructure at the rack level and up to the entire facility? How it's all going to connect together, and how does that impact the design? So I'd like to start off real quick, just quick introductions from everyone, and then we'll get going.
Good morning, y'all. I'm Julie Coates. I am the VP of Lifecycle Management with 1547 Critical Systems Realty. We are owners, operators, and developers. We have about 9 facilities across the country, and 1 in Hawaii, which, one of my personal favorites, because why not? What I do, I work directly with our customers. I'm responsible for our marquee accounts, and I work with all the different disciplines within our organization: operations, construction, sales, and finance. My role is to make sure that the process runs smooth, the customer gets what we want, and it's a win-win for everybody.
Good morning, everybody. My name is Steve Altizer. I'm the CEO and founder of Compu Dynamics. We're a company, if you're in Northern Virginia, you may have heard of us or seen our trucks. We're a construction and building services provider. We've been here for 22 years. In fact, when I look out in the audience, I see a lot of Compu Dynamics people. I feel like I'm talking to half of my own team here. But it's an honor to be here and talking about this subject. This is a subject that's near and dear to my heart, and I'm looking forward to getting into it with y'all.
Morning, everyone. Name is Daggy. I currently lead the data center architecture and engineering portfolio globally for Salesforce. Been with them for a little over 13 years. This is one of my favorite topics. I am actively designing strategies and architectures for AI, and then at the same time using AI to build data centers for AI kind of deal. I know it's ironic, but love to get to it and see how we can discuss it.
Great. Well, as you see, we've got a great panel here today. So let's get a quick start here. Julie, how have the conversations changed for you and your team in the last 12 months, given the adoption of AI workloads and its unique computing needs and requirements?
Yeah, so lots of different conversations. Historically, we're used to seeing 5 to 15 kW per rack, right? That's where the onus was on the owner to develop from the rack out. Now with AI, we're seeing, crazy demands for the amount of power. And that means a lot less space because they're trying to go vertical, more power in a rack. So now the biggest thing that we're seeing changing is our conversations are earlier with our customers, with our vendors, instead of us taking on everything and building out a fit out, if you will, and then a customer coming in and moving in and figuring things out on their end. So we start to reach out to our customers, see where their plans are. What are you looking for? Then we'll involve folks like Daggy and Steve to those conversations. Hey, let's get creative. And once that creativity starts to go, we can start to build out what we're actually looking for. The challenge with AI is nobody really knows where it's going to go. So we start to spitball, and we have to come up with creative ideas.
Great.
Yeah, you mentioned fit out. Fit out is something we do quite a lot of, and we don't even call it fit out anymore. We look at modern data center construction of the white space as white space integration. We call it that because fit out is too simplistic. Today it's a fabric of mechanical and electrical and network utilities all woven together into a very complex system that nobody really knows how to do yet. I think we're all trying to figure it out on the fly, and we're all going to learn a lot over the next 24 months.
And Daggy, with your expertise in the strategies of doing all of that, how have you seen things change in the last 12 months, or maybe a little longer for you since you're kind of at the forefront of some of this?
Yeah, especially after the pandemic, we got hit with the supply chain problems, right? And all of the enterprises that were ahead of the curve with orders got slammed by SKU changes when our GPU or any of the inverse expectations were radically changed, right? Shifted on us. I had orders that didn't even land in the data center that got replaced by another SKU because of obvious reasons. So, like both of these panelists mentioned, the very first attribute of our conversations internally is setting realistic expectations, right? The other one is about even looking out for a viable product or services that can be ordered, and by the time they land, they're not going to be obsolete. And then the third one, if I had to mention it, would be again in the realm of realistic expectations. Whenever people talk about AI, they think that everybody builds greenfield data centers and end-to-end it's AI. It's not. It's never like that. You can have a 480 kilowatt rack that's IR 7000 next to it. I might have a storage array that is 4 kilowatts, right? So when you get greenwashed by liquid cooling or immersion or rear door heat exchangers, setting realistic expectations is extremely important, and we have to neutralize them, right? Because of the diversity and that approach.
Can I say one more thing? I just think this is an amazing time. Everybody in this room is in the data center industry at a really amazing moment in time. I've been in it for many, many years, and there hasn't been a time like this where the evolution has happened so rapidly. We've seen a very slow progress of evolution for 20 years, and now it's overnight. Everything's changing. There's not a single company in the business that isn't undergoing massive upheaval and disruption. Everybody is affected in one way or the other, and it's really exciting.
So, Daggy, I'm going to come back to you here real quick. I know you touched on this a little bit already, and you got into some other places I want to talk about later. But how are the AI data centers different from legacy systems? How are they operated differently? And then the difference between the design side and the operation side, and how you guys are integrating that more together in the AI world.
Very good. There you go. So it's a fully loaded question, right?
Yes.
So let's first separate the way I like to think whenever I strategize is, are you asking this question to, let's say, an infrastructure as a service company or a software as a service company? In the infrastructure as a service world, infrastructure dictates capacity. So you can literally build an AI data center end-to-end with high-density racks, liquid cooling or immersion day one, and whole nine yards.
Right.
When you're a software as a service company like us, and Meta, and PayPal, and Uber, it's not our bread and butter to do brick and mortar builds, right? So the majority of the time, I will go inside my pre-existing build-to-suit, let's say 35 meg or 120 meg, and need to retrofit it, right? I'm still constrained by availability right now. I am tasked with sustainability goals or benchmarks. At the same time, I am refreshing my SKUs to 10 kilowatts, like Julie mentioned, to 480 kilowatts per tile, right? So again, it's an unknown. We're still in the discovery phases, where the very first thing that we will do, obviously, is to structure or create a declarative method of measurement. We have specific tools that we use right now. We're extremely religious about them. One is digital twin. Predominantly in the past, past 13 years, we had internal infrastructure management tools, heavily relied on EPMS and BMS tools. Right now, even before the retrofit or the actual deployment, or like Julie said, the fit out, everything gets rendered using AI for AI. So those are the type of things that we started doing in brownfield. It's very difficult. But in greenfield, it's more relaxed, I would say. When I get into a build-to-suit site, it's pretty much different. But again, digital twins, telemetry-based analysis in forecasting, and you need to have those regressively intaken. Simulations, modeling, there's a bunch of AR things that we do as well to actually forecast the heat, static, dissipation, seismic constraints, for instance. A lot of people talk about direct-to-chip, for instance. Am I building the same data center in Japan? If a certain Richter scale happens, is it beneficial or does it fit overheading them versus under. There's a lot of constraint, right? So, digital twin.
Yeah, great. And Julie, in your world, with the carrier hotels and more legacy systems, how do you see your ecosystem changing with AI?
So we are very early in those stages. We're seeing some of those cloud providers come to us for some larger footprints, and we are getting very creative with what we can do. We have, it's not the 100 megawatts, but we're looking at a 2 megawatt build in one of our facilities, and we can't do everything that they're asking for. So we are looking at, can we use multiple floors, because we're restricted on our height limitations, we're restricted on our structural, a lot of the things that Daggy just pointed out. So where can we spread certain things out? And it's all about creativity. Sometimes I feel like me and the team are, in Disney World, and we're the Imagineers trying to develop the next big fun thing, looking how far out into the future. Our buildings are all over 100 years old. They are very legacy and not even purpose built. So they have all of these weird quirks that you have to solve for to be able to bring in these larger groups.
Great, that sounds very challenging.
Challenging is one word.
Steve, with your experience in white space integration, love the terminology. There are hundreds of data centers that exist today with power available for these new users. Can you modernize an old data center to serve a modern end user?
Gosh, I've been trying to solve this problem for a long time. We're in Northern Virginia. There are probably 100 data centers within 15 minutes of here that are more than 10 years old. And they're not really suitable for today's AI applications at all. 100 kilowatts a square, or 100 watts a square foot, potentially, and you need over 1,000 now today. So if you can figure out how to take a 10 megawatt data center and make it a 100 megawatt data center, you'd be in business, but of course the utility has to cooperate. I think these new buildings are going to be smaller envelopes and much bigger acreage around it for the chillers and the generators and whatever else needs to be outside. So we're changing the configuration of these buildings. And everything inside a legacy data center can be pretty much scrapped. I don't think there's going to be a lot of reuse of existing facilities, reuse of existing UPS systems. In fact, today, I'm hearing people talk about putting air conditioning systems on the UPS and the IT systems on utility power, which is so crazy because 2 years ago, nobody would have done that. And now everything's 100% backwards from the way things used to be, because if you have a 100 kilowatt rack operating without cooling for a brief period of time, you've just fried the entire rack, and you can't do that. That's a lot of expense. So anyway, retrofitting legacy data centers would be awesome, and I hope somebody figures out how to do that, because right here in our backyard, there's a lot of portfolio here that could be utilized that way.
Great. So, kind of building up from there, I think you touched on this a little bit on it does sound like it's be much more efficient to build from the ground up, greenfield versus a brownfield application. There's some challenges there. But we've heard a lot of reports about NVIDIA's Blackwell, right? This new 72 plus GPUs per rack, what their future developments, and from the future standpoint, right, how we're developing to push this rack power densities dramatically. So it's going to really increase the rack level power distribution dramatically by going to that many GPUs per rack. So what's got to change at the rack? I mean, that has to change from what we've used from a legacy standpoint. So Daggy, maybe you want to talk a little bit about how the new technology is going to change the future and what we're looking at from a design and engineering standpoint into the data centers.
Okay. So now I'm going to go back to, remember the two categories?
Yeah.
If I have to answer this question from an infrastructure as a service perspective, let's say AWS, GCP, or Azure, or the hyperscalers per se, my answer would be I would go anything above NVIDIA's GB200 or moving forward, so you have to go directly to liquid. Anything at H100 or below still can do a lot of damage with the air, right, in a hybrid format. So thinking of the previous one, they will definitely go to liquid. Immersion for me is still adorable. It's good, it's achievable, but I don't see it scaling at this particular point, right? There are a lot of use cases. However, for mass deployment of inferences and training and all that good stuff, for IaaS or hyperscalers, yes, they will definitely have to go to liquid. There are products that would be released, I think 17th of January and forward. There are a lot of companies that you traditionally know as OEMs, becoming ODMs, creating consumption-based integrated racks. So the racks that would come to the data centers, our data centers, are pre-aggregated with rear door heat exchangers on the back and ready to intake pipes from the facility, right? That would be the case. However, that is for IaaS. When you come to, let's say, Salesforce Cisco locations, I have over 60 something globally, right? Distributed predominantly in co-locations, like Julie and Steve said. So I am on raised floors, I have to restructure it. Do I have to consider seismic and plumbing and distribution, failure domains? I might have a DoD, FedRAMP, and an HIPAA right here. Who am I addressing this capacity against, right? So in SaaS, capacity test infrastructure, so yeah, 480 kilowatt rack comes. The very first thing I look at it from is not availability or sustainability of the rack. It's from, is it viable? Is it even redundant, right? A lot of people are focused on redistributing power. Just ask yourself, have you ever seen an architecture that has 2N or distributed pipes coming into it? Is it even possible? What happens, like Steve said, we do a failure bypass or failure domain analysis on a pipe. I can't even risk a few seconds of no liquid coming to my rack. I'm gonna lose a $250 million rack. Do you know how expensive that 21-inch rack is? Or those GPUs are, times 71 U's, 10 foot. It's ridiculous, right? So if you do a 2N analysis on that, it's almost $500 million per rack. So who's going to insure it? Who's going to do the handshake, right? The vendor is ready. Our OEM and ODM that lands the GPUs and the racks are ready. Who is our, per se, the pipe guys, right? Plumbers. And it's oversimplified, right? So again, these are the type of things that needs to be discussed to set realistic expectations, because right now we talk about the cooling power, but is the cooling redundant? Show me an architecture that runs distributed power to the rack. It doesn't exist. Or they do over under, but again, we need to set realistic expectations.
Great. Steve, how do you see the rack changing from an integration standpoint that your company's working on?
Things are going to look quite a bit different 5 years from now than they do today. They're going to look a lot different a year from now than they do today. I think the buildings, fortunately, can be sort of generic, but the white space needs to be customized for everybody's application and everybody's rack density. I want to mention this one thing I ran across the other day. If you go to Switch's website, a colo provider Switch, they have a 1 megawatt rack on their website. It's just insane. I guess that's the only application that they've done so far. But everybody knows that if you can do it faster, if you can do it hotter, if it can be done, if there's better performance, it will be done. In that particular one, I think there were 5 liquid services to a single rack. 5? How? Yeah. I don't even understand how that's possible. But if you're putting 5 chill water services to a rack, think about the power going into that rack too. 1 megawatt in a rack. So you take a 100 megawatt building and it's got 100 racks in it. So things are going to look quite a bit different. A lot smaller footprint, but mega utilities going into it.
And I'm going to get back to here in just a second, Julie. So that kind of takes me into how do we ensure scalability in future designs when we're going that dense with that much power into one little location? But you have other products. You talked earlier about storage, and you've got other services that you're running within that data center. How do you design all that into there?
So let's transcend from AI, like reverse transcending.
Okay.
Let's say it didn't exist. Have you guys noticed in the past 5 years, forget GPUs, how CPUs, power utilization, their wattage, extremely increased, right? The current off-shelf product from OEMs can range up to 500 watts per socket. Times 2 per server, that's a kilowatt. Times 48, that's 48 kilowatts per. So when we talk about high-performance compute racks, everybody thinks of AI. No. When you talk about that, for instance, let's use IR7000, one of the racks that is coming next year, early next year. It's 480 kilowatts at a rack level, 21 inches. When you power it up, it's 33 kilowatts. About 25% of it is not GPUs, it's the CPU intake, okay? So why am I mentioning this? this density analysis, the very first thing we have to do is accept the change. The sooner we accept it, the better it is. Moore's Law has died 5 years ago, y'all. It's done, right? So what are our facilities, especially if for enterprises like us, SaaS companies, that do not own, let's say, brick and mortar, or we are attached to a lease? You know how we used to think we were slick in attaching it as a pass-through, and we used to pay $1 per kilowatt? Now I'm going to beg my vendors to actually decouple it, because I would rather pay my power separately, because I'm going to give 90% of my, like Steve mentioned, space. What am I going to do with it? Let's use the 100 megawatt facility as an example that Steve brought up. If I put this 480 kilowatt rack with 2N redundancy for DoD or FedRAMP, I need to allocate another 480 or maintenance bypass or a catcher. Now I'm at 960 per rack. The 40 kilowatts I can use for VRs or any other items, right? Voltage regulation and stuff. So that's the megawatt rack with 480. And then I have, again, imagine, right next to it, I might have a deduplication or a storage array or a database environment. How do I avoid static? How do I even, like you mentioned, can I even be redundant in making sure that I have my failure domain analysis are done? So please give up, accept the change right now. Space and power, they needed to be aggregated for our selfish interest. Now we're going to beg them to decouple it and all of that good stuff. But it kind of is a really good conversation to have right now. Yesterday I was having it with a couple of familiar faces here, where what are we going to do with all of this millions of square foot space that we have in Virginia, especially in Ashburn, right? That glorious data center alley right now is going to be like a corridor, right, with high density racks. Power still is going to be needed, cooling is going to be needed, but the space, a bunch of ice rings, right?
Absolutely. And Julie, with all the things these guys are talking about, the change, the more power, the amount of cooling, the infrastructure that goes into that, how as a facility operator do you guys manage all of that? How do you control all that? How do you make sure all that stuff is up to date and out to your clients so that they're not having any of those issues?
It's, it's a fun challenge. That's for sure. I think it's, staying on top of everything. And that means, training your team, making sure they know what's going on. Anytime they have the opportunity to, get themselves in front of any of the gear, get themselves to actually touch it and work on it. That's a big thing. Getting them involved in any of the commissionings, that's a big deal as well. Make sure your operations team and your construction team or whoever your developer may be who's ever building it out, get them connected. Make sure that they are passing that information on, because knowledge is power, right? The more that the people who are on the floor actually operating everything know, the better that the facility is going to run, the customer is going to be happy, and less likely something to actually happen.
Good.
Chad, we're building a service team specifically for the AI white space, because the unique needs of the liquid cooling systems particularly. I think there are a lot of folks getting into this that haven't figured out how they're going to operate it yet, whether they're going to take responsibility for it or whether they're going to let their tenant take responsibility for it. Downstream of the CDU, it might be tenant's responsibility. There's a lot of risk there. If you get biogrowth in the system or dirt or corrosion, they could shut down your direct-to-chip cooling, and then what happens after that. So I think there's still a lot of questions out there, and we're figuring out as we go.
Great. Anything to add, Daggy?
No, you addressed it perfectly. Just one thing to add is, let's not be greenwashed by all of these items that we're doing with liquid and then lose sight of the real problem like supply chain or availability, right? So because these high density racks still need power, so once we figure it out, we're going to be asked how long would it take? Can we even, is it viable? Is it orderable? Is it sustainable? Is it supportable, right? So let's just not forget that if your busways are still delayed, having a pre-glorified liquid rack doesn't mean anything. The switch is delayed. So the longest lasting lead time item in the data center can still break the data center, and the vendors are blamed for it, right?
Great. All right, as we're running up here on our last 5 minutes or so, let's start with some closing remarks. Let's go down the line here and just talk about lessons learned from recent projects and what you can expect to see in the next 6 to 12 months. Who wants to start?
I'll toss out something. I think we need to see a lot more collaboration, I think, between contractors, owners, architects, engineers, and even manufacturers, because this stuff is changing so fast. We're seeing projects get started with one idea of what's going to go in the white space, and then 6 months later, it completely changes, the density doubles, you have to swap all that ideas out, and everything gets redesigned. So you got to work very closely together to get that implemented quickly. There will be lead times, there's prefabrication going on, you don't want to scrap all that. So I think the more communication, the better.
Yeah, I'm going to echo that. Communication is key. Like I mentioned earlier, those early conversations with your vendors, with your customers, understanding what the end goal actually is, what you're trying to achieve, and then you can plan for it together. That's going to be the big thing. Don't, as the owner or the developer, take it all on yourself, because as Steve just mentioned, it's changing, constantly changing. So make sure you have the right folks looped in.
Okay.
Yeah, so in addition to the communication that was well addressed here, synergy is important. One thing that we are notorious about in the infrastructure world, we like to work in silos and have glorious measurements and announcements coming up. It doesn't matter, right? We need to learn a lot from the software people where they have open infrastructure, they communicate and they create synergy. It's extremely important. If we don't do that, like I told you, from an enterprise perspective as a user, that one longest lasting lead time item would break the data center, will be blamed. That's why most enterprises are currently lifting and shifting into the cloud. I love building data centers, I've done it for over 15 years. But right now I'm trying to model an exit strategy because of a lead time. We're 10 times cheaper to build it in-house, right? So we can help that, one. And then let's discuss, right? As part of synergy, there's a lot of things that we can learn from each other. For instance, as we are preparing, like I said earlier, for AI or building for AI, are there tools that we can use to help us optimize, right? We don't have to worry about traditional BIMs anymore. AI can do actual modern models from an actual drag and drop of a BIM design to create a digital twin of what your data center would look like after 18 months, right? And then simulate, like Steve said earlier, if I use 80% of that power, blah, blah, blah. So communicating, discussing, creating forums, right? That's exactly why I'm here. I'm not trying to sell anything. I don't have any things to sell. I'm a software person. But I'm trying to learn, and we need to conversate. What have we done good? And, panels like this.
Fantastic. Well, I want to thank the panel up here today. Is there any questions out there?
Yeah, so I have 3 here. We'll try to get through all of them. So rapid fire. So from a high level, I know we touched on this a little bit. GPU is fascinating, but cloud continues to be in high demand. What is the future of CPU workloads? If each one of you want to expand on that a little bit, just high level.
They complement each other. They're going to coexist, Adam. Like I mentioned earlier, if you think of a high density rack, about 20% of the power space, any of the utilizations of CPUs. All of your day one need demand for posting, minimum to post or BMC, is still needed to be iterated by the CPUs. Okay, so it's still going to be there. There's a huge demand.
Thanks. Nice and concise. Anyone want to weigh in before the next one? All right, Dag, you got it. Okay, next question. Can older facilities with lower power density be transitioned for storage? And the difficulty there?
I think it really depends on how creative you are with what you're looking at, right? So we have a facility in Portland. It was built in 1913. It has so many quirks. Low ceilings, we're looking at like 11 feet slab to slab. The structure is not so great. So if I want to say yes is the short answer, but it really all depends on how creative you can be with it, right? I think that's going to be where you dive into it. Work with your architects, because that's going to be part of the problem, right? How can they help solve for some of those structural issues? Work with your engineers. Are they going to be able to help turn all of that around and get you that bigger density?
I don't know who answered or who asked that question, but I think that's a great idea. The buildings are networked, they've got power, they've got space. As I understand it, storage doesn't require constant power usage, so it seems like a really logical thing to do.
Adam, one other thing is what we talked about last week in Sacramento, which is modular data centers. I don't want to speak for the enterprise, but for me, I've been experimenting how to retrofit existing massive warehouses for ready-made architectures, right? Those consumption-based models exist. Think of it like an Airbnb of a data center where if I have unused utilization of power or space, can they fund it and I can retrofit it for them in my build-to-suit environment is a thing, right? So again, modular data centers might be in a.
Amazing. Thank you so much. Let's give a round of applause for our speakers here.